Okay. Properties of transversals deal with two things. You have to have parallel lines. Now, we haven't really talked about parallel lines yet. We've talked about perpendicular lines. Perpendicular lines are lines that intersect at exactly 90 degrees. Parallel lines are
lines that are opposite from each other that could go on forever without touching.
Yeah, they're lines that never intersect. The sides of the road, right? We think of that's parallel. The ceiling and the floor. Parallel.
They will sometimes.
I hope the ceiling and the floors don't touch.
Unless it's a
Hopefully
dome.
the ceiling doesn't touch the floor.
Right? So two lines that never intersect. So you have this idea of parallel lines. And then this new idea. Parallel's not new to you, but the new part is this idea of a transversal. And the prefix trans, right? Versal. Means cross. The Transcontinental Railroad went across the continent, right? A transversal is a line that crosses or intersects, right? Parallel lines. A transversal is a line that crosses or intersects parallel lines. It's usually, I'm not going to say all the time, but it's usually diagonal. Okay? I'm also going to highlight the word transversal because I'm going to highlight my transversals in my pictures to make my life a little bit easier. It's another visual cue. So for example, here are some parallel lines. Is that true? I mean, I'm not perfect, right? I'm not a machine. But those are parallel lines. They don't intersect, no matter how far they go. Those are parallel. And I'm going to draw a transversal. I'm going to draw a line that goes through them. Here's my transversal. I have parallel lines, and I've got a line that goes through them. Parallel lines in a transversal. All right, what if I had parallel lines that were horizontal instead of diagonal? Do you think those could have a transversal?
Yes.
Yeah. There's my transversal. Because it crosses the parallel lines. Could my transversal go the opposite way?
Yes.
Instead of going down, it could go up. Sure. I mean, the transversal doesn't matter which way it points. It doesn't matter if it's vertical, if it's horizontal, if it's diagonal. I mean, any of those things, right? Because if you look here, it's diagonal, right? The transversal is diagonal. But in that first example, is the transversal diagonal?
Nope.
No, what's diagonal in the first example?
The parallel.
The parallel lines. So you can't say it's always the diagonal. Most of the time it's the diagonal, but it's not always. It's the odd man out. But here's my dilemma for you, I guess. What if I gave you a pound sign
They're all.
or a hashtag or whatever you want to call it?
They're all transversal.
Are there parallel lines?
Yes.
Yeah. There are parallel lines. There's two sets of parallel lines. There's horizontal and there's vertical. Are there transversals?
Yep.
Yeah.
They're all
To the vertical parallel lines, there are two transversals that are horizontal. And to the horizontal parallel lines, there are two transversals that are vertical. So, I mean, like, could it get more complex? Yeah. Right now, we're sticking with the easy. But, I mean, you know, what if this was it?
They'd only have one because eventually the ones that
How is this picture different from this picture? Now I understand the top one's not perfect. I get that. But what's the transversal? In the top one, we can't pick what the transversals are. Because they're all, quote unquote, transversals, right? In this bottom one, is there a definite answer?
Yes.
Yes.
There's only one because
Oh, there's two. There's still two. There's still two transversals because the transversal crosses parallel lines. And there are two lines that cross parallel lines. But it's different because up here, everything was a transversal. Down here, there's only two transversals. Because two of them will eventually, you guys look, this is your parallel. So what are your transversals? You have two options in this problem. You could choose this guy, or you could choose this guy. It depends. Right? So you have to be able to identify parallel, and you have to be able to identify what intersects the parallels. Maybe there's only one transversal. Today there will only be one. But maybe in the future there will be two transversals. All right. Let's continue on. The relationship between parallel lines and transversals create angle relationships. So we're going to learn about 3 vocabulary terms today. And these 3 vocabulary terms only occur when there are parallel lines and a transversal. If there's no parallel lines, these don't exist. Go ahead. If there's no transversal, these don't exist. Again, mathematicians, not a creative crew, so their definitions are basically their names. Okay? And you'll see what that means in a second. Alternate, interior, angles. Remember, angles is Angles. And I want you to leave, you know, make 3 finger widths on the side. We're going to draw some pictures down the right side or left side, depending what side, right? Alternate interior angles, and then leave some space because we're going to fill this with pictures. Uh-oh. Alternate interior angles. What does the word or phrase alternate mean?
Opposite. You substitute, right?
The opposite, or go back and forth, right? What's the alternate of left?
Right?
Right. What's the alternate of 10 o'clock?
10 o'clock?
10
Look at the clock.
Wouldn't that be 10?
10
What's
a.m.
the alternate of 10?
4. 4 o'clock.
4, right? They're opposite each other. Right? Alternate. Alternate interior angles. Alternate means opposite. What does interior mean?
Inside it.
Inside. So alternate interior angles are
Different
angles
angles.
on opposite. Oops, not an I right there. Opposite. Alternate means opposite. Angles on opposite sides of the transversal. So if one of the angles is on the left, where's the other one? If one of the angles is on top, where's the other one? On bottom. Alternate. So they're on alternate sides of the transversal. Oops. And you told me interior meant what?
Inside.
Inside the parallel lines. Alternate interior angles are on opposite sides of the transversal and inside the parallel lines. Alternate interior angles. So now let's define our next one, number 2. They're alternate exterior angles. Alternate exterior angles. Alternate exterior angles. What do you think those mean? Are they still on opposite sides? Because they're alternate, so they're angles on opposite sides of the transversal. But this time, they're outside the parallel lines. All right, we're going to color code a little bit. Makes life a little bit easier. So if you have your own colored pencils, perfect. If you don't, I'm bringing some by. Share. all that good stuff. You only need 3 different colors. You can share with a buddy, all that jazz. Okay. In this blank space that you left on the right side, I want you to draw parallel lines. And a transversal. And I, again, am going to highlight my transversal because that makes it easier for me. Now, I'm going to use orange because my alternate interior angles is orange. You pick a color and lightly shade over the alternate interior angles. You're making alternate interior angles a color. You're picking a color. I'm using orange because mine is written in orange. Or, you know, like underline it or draw a box around it or squiggles. Identify alternate interior angles as a color. One of the colors that you have at your desk. Mine is orange because I already wrote it in orange. So let's look. In this picture I just drew, alternate interior angles are angles on opposite sides of the transversal and inside the parallel lines. Sometimes it's easier to start backwards. Inside the parallel lines. So where are my parallel lines? Right here. And what's inside? In the middle, right? This part, where my finger is, that's inside, right? And they're on opposite sides of the transversal. So, this angle and where's its opposite? Someone raise your hand. You're going to go point on the board. Where's the opposite? So here's this one. This is inside. Where's its alternate interior angle? John, go point it out. Where's the opposite of this guy? So this guy's on the what? The left side. So we want it to be on the right side. Now here's the trick. I'm going to turn my paper. Are you ready? I'm going to turn it so my parallel lines are horizontal because sometimes that helps me. Alternate. So this side and this one. Are alternate interior angles. What kind of angles are both of them?
Right angles.
They are right angles? No. Is there a box in the corner?
No.
They're both what kind of angles? Acute. There's another pair of alternate interior angles. Where's my other pair? These ones are the acute pair. Where's the other pair?
On the outside.
It can't be on the outside, it's on the inside. It's interior. Sam, go point to him. Yeah, I'm going to do a different thing. I'm going to do kind of a rainbow to show. There are 2 sets of alternate interior angles. You just have to pick. There's an acute set of alternate interior angles, and there's an obtuse set of alternate interior angles. And sometimes, really, in order to see it, you have to turn it so your parallel lines are horizontal. That's a brain thing. All right, we're going to get a different color for alternate exterior angles. I'm using green because mine is green. Shade alternate exterior or make a definition. How do you know which one's going to be alternate exterior? An alternate exterior are angles on opposite sides of the transversal, but they're outside the parallel lines. So if I go back to this and I turn it horizontally, that might help. Well, if there's this one, where's its buddy? Where's its alternate exterior angle? Carver, go point. Yeah. And these are the obtuse pair. I understand my picture is not the best because this top one doesn't look very obtuse, right? But... And is there another pair?
Yes.
Yeah. BB, go point them out. Good. And I'm going to show a rainbow, right? To show that there's different pairs. There's two pairs. Let's write that. There's two pairs of each angle type. There's two pairs. It depends. Are you talking about the acute pair or are you talking about the obtuse pair? What helps you see it? If you're having trouble seeing it, what can you do? What's a hint? Make sure turn it so that your parallel lines are horizontal. All right, there's a third type of angle in here. Or a third type of relationship. Corresponding angles is the third type. So alternate interior, that name makes sense. Alternate, opposite, interior, inside. Alternate exterior, that makes sense. Alternate, opposite, exterior, outside. Corresponding's a little harder. Corresponding angles are angles on the same side. So it's not alternate. That name is gone. These are corresponding. They're on the same side of the transversal. And in the same position on the parallel lines. So let's talk about this for a second. They're both on the left side, or they're both on the right side. They're on the same side. But they're both on same position. All right, let's look at this. All right, this green guy right here, right? something that's corresponding to it, it's on the left, so its corresponding has to be on the left. But what's this green guy's relationship to the parallel line? Where is this green guy, this pom-pom, fountain, whatever it is? What's its relationship to the parallel line? What's its location? It's on the what?
Left.
It's on the left of the transversal. But what's its relationship to the parallel?
On the left parallel.
It's on the what?
Left parallel.
There is no left parallel. The parallel lines are up and down.
Exterior.
It's on the top. It's on the left of the transversal, and it's on the top of the parallel. So its corresponding angle needs to be on the same side, on the left side, and the same position of the parallel line. So since this green pom-pom was on the left top, what's its corresponding angle going to be? On the left top. So they're both on top or both on bottom. And we're going to draw a picture. Don't you worry. Okay. Let's do parallel lines and a transversal, correct? I'm going to highlight my transversal because that just helps me identify which one I'm dealing with. I'm still a little confused, so what can I do to make it easier for my brain to understand what I'm doing?
Horizontal.
Turn it so they're horizontal. The parallel lines need to be horizontal. Okay, what's the definition again of corresponding angles?
Angles on the same side of the transversal and the same position on the parallel lines.
Okay, so they're on the same side of the transversal. I'm going to put a star right here. Where's its corresponding angle? It's on the same side. Okay, this is on the left side, so it's going to have to stay on the left, so I have to deal with just on this side. It's on the same side and in the same position. So it's on top of a parallel line. So can someone go point to its corresponding angle, Olivia? Where's its corresponding angle? It's in the same side, the left, in the same position, the top. Perfect.
Would it be the other side of it?
Same side.
So it's gonna
They're
be,
both on the left and they're both on top.
So there's gonna be one interior and one exterior.
All right. Anybody else see any corresponding angles in there that are on the same side in the same location? There are. There's another pair. Where's another pair of corresponding angles on the same side in the same position? Maddie, go point him out. Okay, describe their side. What side are they on? Are they on the left or the right of the transversal?
Oh.
She said this guy and this guy. Are they on the left or the right of the transversal? They're on the left, so they're on the same side. And what position are they? What position of the parallel line? Are they on the top of the parallel line or the bottom of the parallel line? They're underneath parallel lines, right? The dot is on the bottom side of the parallel line. So this dot, this angle has to be on the dot, right? It's the bottom side. There's another set of corresponding angles. Anybody see it? Refugio, go point it out.
Top right and the bottom top. I don't want to go.
Bottom top one?
Let's put a triangle. This guy, it's on the right side of the transversal and the top side of a parallel line. So its buddy is on the right side and on top of the other parallel. Last but not least, this guy and there are a lot of corresponding angles, aren't there?
Yes. It's crazy.
It's crazy. All right, here's my last thing. Alternate exterior angles. If this guy right here, this orange pom-pom, is 88 degrees, what's this orange pom-pom?
88 degrees.
If this green rainbow was 60 degrees, what's this green rainbow?
60 degrees.
If this red star was 115 degrees, what's this red star?
115 degrees.
So, alternate interior angles, alternate exterior angles, and corresponding angles if one of the pair is 56 degrees, what? The other is equal to 56 degrees. Alternate interior angles are equal to each other. If one's acute, the other one's acute. If one's through 100 degrees, the other one is 100 degrees. Alternate exterior angles are equal to each other. Corresponding angles are equal to each other. There's one relationship we haven't talked about. Are you ready? There's a relationship between alternate interior to its buddy, who is also alternate interior. There is a relationship between alternate exterior to its buddy, who is also alternate exterior. What's the relationship of alternate interior to alternate exterior? What's the relationship between alternate interior and alternate exterior? What does the green pom-pom and the orange pom-pom make together?
180 degrees.
What's that called?
A straight
Starts with an S.
Um,
They're supplementary. Or, look at the picture again. Tell me about the green pom-pom and the orange rainbow. The green pom-pom and the orange rainbow. What's the relationship between the green pom-pom and the orange rainbow? What, BB? They're vertical.